There's a material we've been using in the construction industry for years that most DIYers don't even know about, although it's readily available to them. So if you want the strongest fixing into brick, block, concrete or stone, you've got to be using resin anchors. Resin anchors, or chemical anchors as they're commonly called, are just that. They're essentially two products, two chemicals, and once they're mixed together produce a chemical reaction and go extremely hard. Generally these days they tend to come in these tubes that are used in normal sealant guns. But don't be fooled, there's two actual chemicals in here that only combine when they go through this sort of swirly nozzle, and they mix together, and by the time they come out the end they're well mixed, a bit like epoxy. And once they are mixed, that chemical reaction occurs, and within literally minutes they start going hard. They produce some heat, and maybe after 30 minutes or an hour, depending on the temperature, it's absolutely rock solid, and whatever you're trying to fix will never move again. Generally, as I say, they come in these sort of tube cartridges, but you can get them in vials as well. This is a little bit more old-fashioned, but quite nice if you want to pretend you're in Mission Impossible. These are vials with the two chemicals actually in them. And once the glass is broken and the vials are smashed, the two chemicals mix together and start that reaction. And you essentially do that in the hole that you've drilled, either horizontal or vertical. You drill the hole, you put them in, you smash them in the hole and mix them in the hole, and then you put in your fixing. These have been around near enough forever, but these days really these sort of gun type systems are more popular and I think more available as well. And they're available to the DIYer. As long as you're over 18, there's no reason why you can't just go and buy these. These are really excellent for heavy duty fixings like gate posts to walls, or where you've had a failure and the hole that you've been trying to fix to has now expanded and you end up with a big void that you really can't fill. And these sort of fixings are excellent when you're using things like threaded bar or even rebar into concrete. So what I'm going to do today is show you how to use one of these into concrete, how to prepare the hole properly, and we'll do a little bit of a test on how strong it is as well. And also, if you don't want to use my system that I showed you a couple of weeks ago on how to get a really good fixing into a dot and dab wall, I'll show you something on the market that you can get a really good fixing for the heaviest of televisions that will never ever fail as well. So let's get going. I'm going to drill a hole and I'll show you how to prepare it ready for this resin. To trial this fixing, I'm choosing the most convenient lump of concrete I have, which is my workshop floor again. So I move my workbench to give me some room and bring out my old faithful Titan SDS drill. I'm drilling a 12mm hole for the anchor, but as long as it's obviously at least the size of the fixing you're putting in, the size doesn't really matter. So that's the hole drilled, and what I'm going to be using in it today is this raw plug Chem 2 fixing kit. It's essentially the same material as all the others. But the great thing about this is in one box it contains everything you need as a DIYer to put up 4 good fixings. It's got the bolts and the nuts, a couple of the mixing nozzles, and some other bits and pieces that I'll show you a little bit later. What I would suggest is if you had lots of fixings to do, then you're probably better off buying one of the other tubes, but then you will have to buy all the other bits and pieces separately. So it's really up to you, but this is quite a nice kit for the DIYer. So before I do any of this, the first thing is I have to prepare that hole ready for this resin anchor, and that means blowing it out and also brushing it out. Although the resin ends up incredibly hard and strong, if it's got a layer of dust between it and the hole you're putting it in, it'll just end up pulling out. So getting the dust and debris out of the hole is an important step in this process. I'm using an air blower here to push the dust out of the hole, but you can buy hand pumps for this. And it's also recommended that the sides are brushed. I'm using a cut down toothbrush here. This process should ideally be repeated until the dust stops coming out. Once everything is ready to go and I've read the instructions for the 5th time, I load the resin into the gun and pop the seal. The first squirt needs to be done on a piece of paper or something sacrificial to make sure that the two components are mixed properly. This is coming out a single consistent colour, so I know that it is. Starting with the tube at the bottom, I fill the hole around about 3/4 full, then insert the fix in by screwing it into the resin. It's really important to wear gloves while you're doing this, as these are serious chemicals and best just not to get them on your skin. The other thing you get in the kit, as well as a spare nozzle, because this stuff does go off very quickly, so you definitely need a spare nozzle, are these inserts, and you get 4 of them. And they're essentially 12mm diameter inserts, about 2 inches long or 50mm long. And they're designed to be used in hollow materials or materials with voids in, like hollow brickwork, or in a dot and dab wall where you've got that void between the plasterboard and the blockwork. So I'm going to show you how to use this in the dot and dab wall in my dot and dab mock-up, which you would have seen from a previous video. I drill a 12mm hole to suit the insert, and then a couple of intersecting holes so we can actually see how the insert performs. I prepare the hole in the same way as in the concrete and pop in the plastic insert. I'm turning the block around here just so it's easier to see what's happening. It doesn't matter which way a hole is orientated. The resin is viscous enough to stay put even in a vertical overhead hole. This insert is a type of plastic mesh which contains the resin but also allows it to push out under pressure into the surrounding area. Once filled, the cap goes on the top and I can squeeze some more into the hole, filling up the adjacent voids. While I have the material in the gun, I decide to squirt out a lump so I can see how strong it is once it sets. I haven't used all the resin in this cartridge yet, so I see if I can clean out the top where the two chemicals have mixed to allow me to use it again. One of the chemicals is in a bag in the cartridge, the top of which is about 1/2 inch from the opening. So I clean out all the material to that point, so hopefully the two separate parts will be free to flow out again. So I've just left the resin an hour to cure, and let's have a quick look at this sample here. I don't know if you can see, but even these really small let me just put it against here, even these really small sort of pinnacles at the end, incredibly strong. If I just get my knife here, this is just after an hour. Wow. So there is no way I'm breaking that. That's like trying to rip steel apart. That is incredibly strong. So it doesn't surprise you that it fixes really well. Let's go and have a look at the fixing in concrete. That feels pretty solid. I'm just going to pack it out and put one of my steel plates on. See how far we can tighten this up. I don't have any test equipment to measure the torque that I'm putting on this nut, but from experience I can tell that nothing here is moving anytime soon. Oh man. Okay, so that isn't going anywhere, and that's only just after an hour. And that's not surprising. I've done this test many times on site when we've had to prove the capacity of the fixings with chemical anchors. And nearly every time, if it's actually got to failure, it will be the failure of the material around the fixing rather than the actual resin. And that just shows you how hard and how strong the resin really is. So essentially what's happening here is the plasterboard is failing, and all I'm doing is winding this piece of steel into the squishy plasterboard rather than anything else pulling out. You don't really have to tighten it that far. If you had two of these, then you would have stopped a lot earlier, but there's no way that's going anywhere. So I think you can see from these two examples how strong and how permanent resin anchors are. And I suppose that's the only downside to them really, is that they really are permanent. If you've got a threaded bar or fixing in a hole with resin that's cured and gone off, it's never going to move again unless you take a disc cutter to it. This sample that I squeezed out just over an hour ago, absolutely solid. I wouldn't like to drill a hole through that. That would be quite tough to do. And my miter saw really struggled just to cut the end off. So this is a really hard and strong material. Now, one of the challenges with using a material like this is the short amount of working time you've got. Once it's mixed through the nozzle, the instructions say you've got about 9 minutes. I think you've got more like 5 minutes. So by the time you start mixing it, you've got to have all your holes drilled, everything cleaned out, and all your fixings lined up, ready to go. So once you start, there's no stopping you until you complete. But excellent for filling holes that are maybe oversized in brickwork where it's worn away and you really need somehow to re-establish a really good fixing. So something that maybe, if you don't need it now, that you can always think about using in the future. So I hope you enjoyed this video. If you have, please check out the other ones on the channel and please subscribe. And please go and have a look at our Patreon page where you can support us over there and you get extra content and extra weekly videos as well. So until next time, I'll see you then. Jesus.